Hello again. We're going to be starting a new unit on differential equations. So today we're going to talk about how to set up those differential equations. So let's get started. First of all, what is a differential equation? What it is, it's an equation that actually contains derivatives in it. So anything that has a dy dx or an f prime or something like that in it where we need to solve for the actual function itself. So the goal is to use that and integrate it somehow, find the antiderivative somehow to create an equation that doesn't have derivatives in it. So for example, here's an easy example. We've done this before earlier in the year. If we had dy dx equals 4x to the third, then I could integrate both sides and get that y equals x to the fourth plus c, and I might have some boundary condition or initial condition that allows me to figure out what the value of c is. Okay, this is called a general solution with that c. Then once I get a boundary condition like something that says the curve passes through 0, 2, then I can use that to figure out that the actual solution is y equals x to the fourth plus 2. We've done those before, but they're not always that simple. So a couple of definitions before we start. The rate of change, as we've talked about, that does mean the derivative. Another definition, if a variable is proportional to x, what that means is that variable is a constant multiple of x. For example, sum k times x. And then if a variable is inversely proportional to x, what that means is there's a relationship of k divided by x instead of k multiplied by x. If there's a rate of increase, what that means is the derivative is positive, and if there's a rate of decrease, that means that the derivative is negative. So just some definitions you'll need to know for this unit. So here's an example. We have a classic car. The value of it in dollars increases at a rate that's proportional to the time in years since it was restored. 1 year after it was restored, the value of the car was $50,000, and at that point it was increasing at the rate of $300 per year. So we need to find the value of the car 10 years after it was restored. So let's get started. The derivative is 300 times t. So the rate of increase was proportional to time, and so that proportion is 300 times time. All right, so if I integrate both sides, I get that dv dt just becomes v, and then the 300t becomes the antiderivative of 300t, which is just 150t squared plus c. Now I just need to figure out what that constant c is equal to. To do that, I'm going to use the fact that after 1 year, it was worth $50,000. So at time 1, the cost was $50,000. All right, so if I replace those and I solve for c, I get that c is 49,850. So my actual equation is v equals 150 times t squared plus 49,850. Now I need to figure out how much it was worth 10 years after it was restored. So to do that, I'm going to plug in t equals 10, and I will get a value of 64,850. So the car will be worth $64,850 after 10 years. So that's just a little introduction on how to set up differential equations. If you have any questions, please let me know, and I will see you tomorrow.